Hello, 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 hello. Can you hear me? Hello, hello. Any students online? Hello. Yes, yes. ICSE ಕ್ಲಾಸ್ 10 ವಿದ್ಯಾರ್ಥಿಗಳು ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಪ್ರಾರ್ಥನೆಯನ್ನು ಸಲ್ಲಿಸಿ ಇಂದಿನ ಎಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆಯನ್ನು ಸಲ್ಲಿಸಿರಿ. ಟೇಕ್ ಎ ಡೀಪ್ ಬ್ರೆತ್ಸ್. Yes, good evening, my dear students. Okay, let us continue with periodic properties, the trends in periodic properties. We have to discuss today. The first chapter, periodic properties. What are periodic properties? We are discussing periodic properties. Today we'll start learning trends in periodic properties. Trends means variation. Trends in periodic properties. Periodic properties. Different periodic properties we are discussing, and the first periodic property is atomic size. Atomic size, we started learning atomic size already. Second periodic property is metallic property. Metallic property. And the third periodic property is non-metallic property. Non-metallic property. And the fourth periodic property is ionization energy, ionization potential or ionization energy. How do they vary along the period and down the group is called as the trends in physical properties. Next one is electron affinity. Electron affinity. Right? Okay, so these are some of the trends we are going to discuss. 5 periodic properties, their trends. Hello, welcome. You can't know your name. You can write your name there so that I can call you by your names. Your name is not, you send your name in the WhatsApp group. Join the WhatsApp group. I will send you the question paper after completion of every chapter. Right, I will solve them in the next period so that you can evaluate your paper. So trends, now observe here, what is the meaning of trends is, somebody asked, when you teach trends, yes, now I started teaching trends now. So down the group and along the period, the basic reason for all these variations, trends means variations, either decrease or increase, variations. Along the period, as we move along the period, in the last period we studied that cell remains constant. cell remains same. Cell remains same. Here down the group what happens? This is along the period. Along the period. You take any along the period, cell remains the same. To the same cell, one electron will enter successively. Means if you take the first period, second period, third period, fourth period, only up to fourth period we are discussing for your class. You know the elements present in the first period, second period, third period, fourth period. First period, second period, third period, fourth period. In the first period there are only two elements. One is hydrogen and the second period will contain lithium with atomic number 3. 4 is beryllium, 5 is boron, 6 is carbon, 7 is nitrogen, 8 is oxygen, 9th is fluorine, 10th is neon. In the third period you have 11 is sodium, 12 is calcium, 13 is aluminium, 14 is carbon, 15 is phosphorus, that is 14 is silicon, phosphorus, sulfur, chlorine and argon. Fourth period starts from potassium, 19, calcium will be below calcium. I think you have magnesium here, magnesium 12, lithium 3, 4, 5, 6, 7, 8, 9, 10 atomic number, 11, 12, 13, 14, 15, 16, 17, 18. Okay, fourth period will contain long period. Said that second period is a short period of how many elements? 8. Third period is a short period of how many elements? 8. And fourth period is a long period of 18 elements. Because along with after potassium atomic number 19, you have got calcium atomic number 20. Then comes scandium atomic number 21 to zinc atomic number 30, transition elements. Are you getting me? So then again 13th group starts here. So this is a thing. What happens? You observe. The cell number remains the same. One electron will be added to the reason down the group. What happens is the cell increases. Cell increases by 1 unit. Right? What happens to the size, atomic size? I was talking to you about atomic size. One by one we will see. Right? Atomic size. With the details I will discuss with you. The main reason for this is, along the period what happens is, generally the metals, that is alkali metals which are present here, first one is hydrogen, lithium, sodium, potassium, right, rubidium, cesium, francium, that is 5, 6, 7 down the group. Along the period, if you see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, just will observe. What is happening to the electronic configuration is, here the electronic configuration of lithium is 2-1. Here 2-2, here 2-3, here 2-4, here 2-5 minus 5, 2-5 cannot write, right? You will get what? 8 minus 5 is 3, 2. Electronic configuration we can write it as 2 plus 4, 6, 2, 5, 2, 6, 2, 8, 2, 7, 2, 8. Observe, means electrons are entering into the same cell. Which cell? Second cell. Observe, this is the first cell, this is the second cell. Means K cell and L cell in the second period, electrons are entering. And here, as one electron increases, there are two things here. One is called as atomic size. What is atomic size? Average distance between the nucleus. Average distance between the nucleus and the outermost shell is called as the atomic radius. Observe this particular atomic radius. What happens is, as you move from left to right, one electron is entering, no doubt, to the same cell. Here in the lithium there was one atom. I will show along the period first. Cell will remain same. This is nucleus, this is K cell, this is L cell. So when one electron enters, one proton will also enter. As a result, nuclear charge increases. Along the period, what happens is, size remains same. Size remains same. What is the nuclear charge? Nuclear charge is positive charge. Electrons are negatively charged. Right? Nuclear charge goes on increasing. Number of protons when increase, nuclear charge increases. Effective nuclear charge increases. Keeping the size same, to the same cell electrons will enter. As a result, this particular electron cloud or outermost shell is pulled by the nuclear charge is positive charge. It will be pulled up more towards the nucleus, like this. Size will go on decreasing, right? The beryllium will have smaller size than lithium, and boron will have still smaller size. I will give the correct values. And like this, size goes on decreasing, but in inert gases it increases. Along the period, atomic size, along the period decreases. Why it should decrease? Because to the same cell electrons are entering, but effective nuclear charge increases. As effective nuclear charge increases, the outermost cell is pulled towards the nucleus. Outermost cell will contain electrons, negatively charged electrons. Nuclear charge as goes on increasing, because one proton is also increasing as you move along from left to right along the period. Right, the atomic size will go on decreasing. Why it decreases means the outermost shell is pulled towards the nucleus. Hence, atomic size or all these properties. Hence, atomic size or atomic radius decreases. What is the trend of atomic size along the period? The trend of atomic size along the period, as you move from left to right along the period, one electron is successively entered. Whenever one electron enters, one proton also enters. As a result, effective nuclear charge, effect of nuclear charge on the valence shell will go on what? Increasing. Therefore, the electron cloud shrinks, means is pulled towards the nucleus. Therefore, size goes on decreasing. I will give the definite values along the period now. This lithium has got atomic size. I have got data here. 152 picometer. Picometer means 10 raised to 1 picometer means 10 raised to minus 12 meter. Remember, very small, 152 picometer. Then you can see beryllium, it is 112 picometer. I will write the picometers. 152 picometer, it becomes 112 picometer. Then boron, boron will have 88 picometer size. And if you see carbon, it is 77 picometer. Observe what is happening. They have measured it. Nitrogen atomic size is 70 picometer. Oxygen atomic size is 66 picometer. And that of fluorine is 64 picometer. And For neon, suddenly it is increased to 112 picometer. You may ask me question. See, 152, what is happening to the size? Atomic size 152 picometer to 112, decreasing 70, 66, 64, but suddenly increases. Why? Because in case of inert gases, outermost shell is completely filled, you know. They have got stable octet. As outermost shells are completely filled, due to the repulsion of the electron, like charges repel each other. Therefore, due to the repulsion, their size will increase. You can have a note here. Exception. Note. Along the period, at the end, the size of inert gases, reasoning will be asked, application questions. Inert gas suddenly increases. Give reason. Have a note. See, 112 was beryllium. Then it was successively decreasing up to halogens, fluorine, but suddenly in neon it becomes 112 picometer. The reason for this is, you may be asked a 1 mark question or multiple choice questions. Reason for this will be, inert gases have completely filled. Inert gases have completely filled cells. Completely filled cells. Hence, due to mutual repulsion of valence electron, remember, mutual repulsion of valence electrons, the electron cloud expands. We call it as electron cloud. Expands. Write this reason, it is a perfect reason. Expands. Hence, the size of the inert gases in the period will be highest. It is exceptionally, this is exceptionally, according to the trend, atomic size from left right should decrease. Why it should decrease? I have given reason. Nuclear charge increases. As a result, nuclear charge increases along the period because one proton is entering, keeping the size same. Outermost shell is pulled towards the nucleus, hence atomic size should decrease. But exceptionally, inert gas are showing increase 112 picometer. And therefore, you can say that the reason for this is, along the period, what is happening is, in case of inert gases, all the electrons are completely filled. Therefore, inert gases, due to the mutual repulsion of the valence electron cloud expands. Therefore, atomic size suddenly increases. I hope you got the reason. Note down the reason. Then we will see trend of atomic size down the group. Now, I will show you down the group. So, what is the happening down the group? We will try to understand. There is one basic reason for all of them. One is a nuclear charge. Another one is increase in the atomic size. I will take a group 1 elements. You have hydrogen, atomic number 1, electronic configuration is 1. Next comes lithium, atomic number 3. Lithium, sodium, atomic number 11, and potassium, atomic number 19. Even I have got values of atomic number 19. Then you can take rubidium, atomic number 37, cesium, atomic number 55. Let's do for this purpose. What is happening here? This is in the first period. This is in the second period. This is in the third period. This is in the fourth period. This is in the fifth period. This in every period corresponds to the new cell. Now what is happening here is, in case of hydrogen there was only one cell, cell number 1. In lithium, now the cell number becomes 2. In sodium, the cell number becomes 3. In potassium, cell number becomes 4. In rubidium, cell number becomes 5. 1, 2, 3, 4, 5. Observe yourself. In cesium, cell number becomes 6. Cesium. See, you can get the reason. 1, 2, 3, 4, 5 and 6. Means what? Down the group, what is happening is, down the group, from top to bottom, down the group, at every element down the group, new cell is introduced. Therefore, there is a sudden increase in the atomic size. Observe. But nuclear charge also increases. Both of them are increasing, because here is 1 proton, here 3 protons, 11 protons, 19 protons in the nucleus, 37 protons. Both of them are competing. Means down the group, two things are happening. Down the group, what are the two things that are happening is, at every element, new cell is introduced. New cell is introduced. Let me rub this, just for your understanding. I have shown you here. New cell is introduced. As a result, atomic size increases, isn't it? First cell, second cell increase, and nuclear charge also increases. Nuclear charge means positive charge also increases. But both of them are competing here. Two things are competing. One is atomic size is increasing, and effective nuclear charge is also increasing. Of them, increase in the atomic size dominates over nuclear charge. Increase in atomic size dominates the increase in nuclear charge. Hence, atomic size trend of atomic size from top to bottom in the group is, atomic size should increase. This is our analysis, theoretical analysis, that is qualitative analysis. Now quantitatively, I have got the values calculated by the scientists. I will give the values. Theoretically, this is our observation. So that is at every element down the group, from top to bottom down the group, at every element, every period number corresponds to the new cell. Therefore, there is sudden increase in atomic size. But simultaneously, number of protons are also suddenly increasing. Means nuclear charge is also increasing. Both of them are competing. Of them, the increase in the atomic size dominates over the increase in the nuclear charge. Therefore, according to our this particular qualitative analysis, not quantitative, and will it agree with the values? Atomic size should increase. I got the values. Hydrogen has got atomic size 37 picometer. Observe the experimentally determined value. It is data. Lithium 152 picometer. See, sudden increase from 37 to 152, and sodium is 186 picometer. See, again by increase at least by 30 units. So potassium is 231 picometer. Observe and rubidium is 244 picometer, observe, and cesium is 262 picometer. What is your quantitative values determined by the experimental values? This is a theoretical analysis. Yes, that is agreement. Is it increasing or decreasing? 37 increased to 152. For sodium 186, 231, 244 picometer, 262. Means what is the trend of atomic size down the group? The trend of atomic size down the group is, it goes on increasing. Reason is this. You will not be asked these values, you will be asked a reason. Explain the trends of the atomic size down the group. Atomic size down the group increases. Explain, give reason. This reason you have to give. Means a new cell is introduced. Along with that, nuclear charge also increases, but increase in the atomic size dominates over. You can observe even experimental values. Increase in the atomic size dominates over nuclear charge. Therefore, you can observe down the group atomic size increases. That's all. The trends of atomic size. First periodic property. We'll move on to the next periodic property. Metallic and non-metallic properties. I want to talk about you. What is a metallic property? What are the trends of the metallic property? Right? First, you try to understand what are metals and non-metals. Second trend is metallic property. Metallic property. And third trend is non-metallic property. Both of them together I will discuss. Non-metallic property. First of all, you try to understand what is the property of a metal. See, whenever you write sodium chloride, how do you write sodium chloride? Sodium Na plus 1, chloride minus 1. We studied in the bridge course. Means metals. Is there any compound? We call it as sodium chloride. Sodium chloride. While writing sodium chloride, metals are written on the left, non-metals are written on the right. Generally, non-metals will have the negative charge. Metals will have the positive charge. You take any metals. For example, ferric oxide. If you take Fe plus 3 is a metal, oxide is a non-metal. This is iron is metal, non-metal. What do you observe from this? You can observe that metal become Na plus, iron becomes Fe plus 3. How it is possible? Observe here. If I take sodium, what is the electronic configuration of sodium? 11. I will show you. 11. How many electrons in the K cell? 2. L cell will be 1, 2, 3. What is the period number of sodium? 3, 4, 5, 6, 7, 8. 2, 8. Atomic number of sodium is 11. It is 281. 281. Observe. One electron is present in the valence cell. If I take a chlorine as an example, let us take the simple example. Here sodium is a metal, chlorine is a non-metal, chloride is a non-metal. Observe what happens. You try to understand first metallic property and non-metallic property. Before you see the trend, I expect you to study. And if I take a chlorine, chlorine will have atomic number 17, electronic configuration is 288, 287. Means there are 3 cells in it. K cell, L cell, M cell. You studied in the 9th standard. K cell will have 2 electrons. L cell will have 1, 2, 3, 4, 5, 6, 7, 8. Right? And M cell will have 1, 2, 3, 4, 5, 6, 7. Observe here. Generally, every metal has got a tendency. This is sodium with atomic number 11. This is chlorine with atomic number 17. See, there is a tendency in all the elements to attain stable octet. Observe here. 8 electrons. Means sodium, if it loses 1 electron, it becomes stable electronic configuration of neon. Chlorine, by gaining 1 electron, it becomes what? Argon. Atomic number 18. Therefore, most of the non-metals or we studied in the periodic table or on the extreme right of the periodic table, the metals are present on the left side. Why? Because the sodium, by losing electron, it loses electron. How? This is sodium atom. Once it loses this electron, now how many protons are left here? Plus 11 protons are left. Now how many electrons are left here? 8 plus 2 minus 10 electron. Plus 11 minus 10 becomes what? It becomes Na plus 1 ion plus 1 electron. By losing this electron, it will lose this electron and transfer this electron to chlorine before formation of sodium chloride. By losing this electron, it becomes what? Neon. Therefore, metals have the tendency to lose what? Electrons and form positive ions. What is the property of the non-metals? So, non-metals are those elements. They are placed on the extreme right. This chlorine you can take as an example. It contains 17. If it gains one electron given by this sodium, it becomes a chlorine atom. Such two chlorine atoms will combine, forming chlorine gas. Means, and it forms by gaining one electron. See, how many protons are there in it? Plus 17 proton. Once sodium gives one electron to it, now it becomes minus 18 electron. Plus 17 minus 18 becomes what? Minus 1. Therefore, metals have got the tendency to lose electron. This property is called as metallic property. The property of an element to lose electron is called as metallic property. The property of an element to gain electron is called as non-metallic property. This property of an element to lose electron is also called as electropositivity. What it is called as? Most of the metals are electropositive, means have the tendency to lose electron. Non-metals have got the property called as electronegativity. What they have? Electronegativity. Electronegativity means the property of an element to gain electron and form a negative ion. Property of a metal to lose one or more electrons and form what? A positive ion. That is what is called as valency. Valency of sodium is plus 1. During combining with chlorine, sodium will lose electron and chlorine will gain that electron and form sodium chloride. It is chemical bonding. We studied in short, we are studying in detail in the next chapter. Second chapter is chemical bonding. So that is the metallic and non-metallic property. Therefore, what is the trend you can observe along the period and down the group? We will check it by taking definite period. How the trends will take place? I will take the element before we see the trends down the group. One thing we have to learn here, very important thing. Sodium becomes Na plus ion plus 1 electron. Just now you wrote. Okay. Now, if you observe, what happens to the size? Sodium 1, 2, 3. Atomic number is 11. In K cell, there are 2 electrons. And L cell, second cell, 1, 2, 3, 4, 5, 6, 7, 8. And in third cell, this is first cell, second cell, third cell, there is 1 electron. So, when it loses this 1 electron, the third cell is vanished. As a result, in sodium plus ion, what happens? Observe. You will get 1, 2, 3, 4, 5, 6, 7, 8. Generally, atoms will have more atomic size than the cation. Remember, generally, atomic size of sodium metal or radius of sodium atom is greater than radius of Na plus ion, or even you can say radius of the atom, neutral atom, is always greater than radius of positive ion is called as cation. Cation is called as positive ion. Remember this point. Size of the radius of the atom will be always greater than size of the cation. Remember this note, very important note. You may be asked in multiple choice questions. Similarly, we will take the case of chlorine, which is a non-metal. Chlorine gains one electron, it becomes what? Cl minus ion. Now, what is the electronic orbital structure of it? This is nucleus, K cell, L cell, M cell. How many electrons are present in chlorine atom? 17. Now, 2 electrons in the K cell, 8 electrons in the L cell, 1, 2, 3, 4, 5, 6, 7, 8. We learnt in the 9th standard. And 7 electrons in the outermost shell. Observe 1, 2, 3, 4, 5, 6, 7 electrons. Once it becomes chloride ion, one of the electron increased here. When one of the electron increased here due to the repulsion size, this is atom. Once it becomes a chloride ion, what happens is 1, 2, K cell, L cell, and this becomes bigger because when one extra electron is added, 1, 2, 3, 4, 5, 6, 7, 8. Here 1, 2, this is nucleus. 1, 2, 3, 4, 5, 6, 7, 8. Now once one electron is added, due to the electron-electron repulsion, slightly size increases. Therefore, radius of Cl will be less than radius of Cl minus, or in general you can say that radius of neutral atom will be always less than radius of anion. Anion is negative ion. Are you getting me? Remember this one with respect to this. Radius of neutral atom is always greater than radius of positive ion. Cation means positive ion. Radius of neutral atom is always less than radius of anion, that is negative ion. Have this note. The reason for this is here one cell vanishes, therefore electron cloud is attracted towards the nucleus, therefore size decreases. Here one electron is increased, therefore Cl minus ion will have the more radius. I hope you got it. Now, if you observe along the period from left to right, if you observe along the period and down the group, how this particular trend takes place. Okay. If I take along the period, second period I will take what is the metallic property and how the non-metallic property changes. I will go on writing the second period element. Period 2. You have lithium, next you have beryllium, boron, carbon, nitrogen, oxygen, fluorine. If you take of them, lithium and beryllium are pure metals. Boron this is present in first group, this is present in second group. Here it is 13, 14 group, 15 group, 16 group, 17 group. This particular boron has got property of both metals and non-metals. Property of both metals and non-metals. Such elements which have got properties of both metals and non-metals are called as metallites. Metallites. They have some properties of the metals. It can behave like metal as well as non-metal. Even you can take aluminium. Right? They can behave like a metallites. And if you come to carbon, nitrogen, oxygen and fluorine, they are non-metals. Non-metals. What is your observation of the metallic property? See, as you move along the period, the metallic property goes on decreasing along the period. You can write the trend along the period from left to right, left to right, metallic property decreases metallic property decreases. That is a trend. Because what happens is, and this particular lithium, beryllium are purest metals, their size is big. Therefore, the influence of the nucleus on the outermost shell will be less. Therefore, outermost shell electrons can be easily removed. As you move from left to right, again the reason is atomic size. Atomic size decreases. Atomic size along the period. Reason, if you want to give the reason for this, why along the period metallic property decreases, means along first reason is along the period atomic size increases. Just now we observed atomic size increases. Atomic size increases. Along the period atomic size increases. Okay, along the period atomic size, when atomic size increases, atomic size along the period decreases. Just now we observed the values of atomic size, just now we observed, means they come very, very close. Just now I have shown you that if you take lithium, atomic size is, if I write the atomic size of lithium, it is 152, 112, boron is 88, and carbon is 77, nitrogen is 70, oxygen is 66, fluorine is 64. So, this particular effect, which elements have got largest atomic size? Largest atomic size are lithium. Atomic size means distance between the nucleus and the outermost shell will be large. Hence, influence of the nucleus on them will be less. Therefore, these electrons can be easily removed. Therefore, this is the metallic property. What is the metallic property? Metallic property is the ability to lose electrons readily. As we move along the period, what happens is atomic size decreases, means the outermost shell comes very close to what? Nucleus. Means the nuclear influence of the nuclear charge on it will go on increasing. Hence, the valence electrons will be under the control of nucleus. Therefore, to remove electron, it becomes more difficult. As atomic size decreases, tendency to lose electron decreases due to influence of nuclear charge, due to influence of nuclear charge, because the outermost shell comes closer and closer to the nucleus. Therefore, due to the influence of nuclear charge, tendency to lose electron decreases due to influence of nuclear charge. Therefore, metallic property, yes, decreases along the period. They will not ask you values along the period. They will ask you reasonings. ICSE students, listen to me carefully. Most of the questions in ICSE will appear on application based analysis, analytical thinking. Why metallic property decrease along the period? If the question is asked, your answer must be, you have to take the original thing. Along the period from left to right, atomic size decreases. As atomic size decreases, the outermost shell comes closer and closer to the nucleus. Then to remove the electron becomes, you need more energy. Therefore, the tendency to lose electron decreases due to the influence of the nuclear charge. Therefore, metallic property decreases along the period. I hope you understood, my dear student. That's all for today. We'll continue remaining properties on Monday. Tomorrow, maths period, I will just inform you, because I am setting up another studio in Gadag. On Saturday, Sunday, I will be in Gadag. I will take these equipments and set up there, and I will take a live stream mostly evening. I will tell you once it is ready. Okay. Okay, and please wait for my information. Mathematics Monday, as usual, we will continue with periodic properties. Next week, I am completing the chapter. Be ready for a test and join the WhatsApp group. I will send the test paper in the live stream only, or earlier, 1 hour before. You write it, and then I will start the live stream. Before the live stream, I will send you 40 minutes earlier. You write there, and I will, at the time of live stream, I will solve them. You have to evaluate. Written test, multiple choice questions. We are planning to upload it in Vidim's app. Download the Vidim's app. There we have already created the courses. There I will upload the multiple choice question. They are time-based quiz. Only app will analyze and give you the answer. Just give me some time. I will make the arrangement and inform you how to use it. That's all, my dear students. Good night. If you like the explanation and the teaching of Lokji, myself Desai sir, okay, with 27 plus year experience, I can train you properly in both chemistry and mathematics, right? And if you like it, you invite your more friends to come on live. There are very few students in live stream. Live stream, you can interact here, ask doubts, and you can introduce yourself. I will be seeing your chats there, and actively participate in the live stream. You can comment there, you can write the answers, because it is required. Even when I take the test, when I give MCQ questions here, I'll ask you which one is correct choice. You have to answer there. Okay, therefore come to the live stream. Therefore I am not recording it. I am coming live stream, natural class. And if you like it, subscribe it and download the Vidim's app just for 540 rupees. Nominal fees will be there. And we are doing it to serve education field in general, student community in particular. We want to generate best performance from our Lokji family. You are joining to my Lokji family. I will take care of you. Bye bye. See you tomorrow. I will inform you afternoon. Once everything is ready there in Gadag, because I am 2 days I will stay in Gadag, 5 days I will be in Dharwad. Okay, bye bye. See you. If it is not possible, we'll meet on Monday. Okay, fine. Okay, Pala.